Yeah. Good afternoon to one and all. Welcome, Dr. Aditi, and I welcome all my colleagues who have joined for this TLC Talk series. TLC Talk is one of the initiative of the Teaching Learning Center of SASTRA, through which we want to have experts on what they see as education and what they are pursuing is in terms of their educational research or initiatives, so that we can also emulate, adapt, adopt good practices from our own peers interested in education. Today, I'm very happy to have Dr. Aditi with us. Dr. Aditi is an assistant teaching professor with the Center for Creative Learning, CCL, and the Department of Humanities and Social Sciences at IIT Gandhinagar. She obtained an MS in Electrical Engineering from Ohio State University and a PhD in Educational Technology from IIT Bombay, and has about 12 years of experience in designing novel learning environments grounded in learning theory and research. Before joining IIT Gandhinagar, she was a postdoc scientist as computer-human interaction in learning and instruction lab with Professor Perry. In her work, she uses a range of educational technologies from software to toys and educational robots, while centering making as a learning activity. Her current research in engineering education focuses on examining the effectiveness and challenges of project-based learning in undergraduate design and prototype engineering courses meant to foster innovation and interest in engineering. This is a very short, brief bio sketch of Dr. Aditi, and I'm not going to talk more on the title. It's going to be a very nice title, more relevant to us, of making confident and innovative engineers a holistic reimagining of engineering education. I'm sure the next 1 hour would be an eye-opener to many of us. I once again invite Dr. Aditi. Thanks for accepting our invitation and giving this online talk. I request all my colleagues who have joined online, feel free to text your query in the chat, in the Google Gmeet chat itself. Once the presentation is over, either Dr. Aditi herself will read through it, or otherwise I can curate. I have some questions which I have already got through the registration form, and that would be taken up. Thanks to all, and thanks to Dr. Aditi. It's over to you.
Thank you, Professor Naren. Thank you for that, for this invitation and for your kind introduction. So yes, I have the questions that a lot of you had asked in your registration form. So thank you for that. Hopefully, I will be addressing some of them as we go along. But at the end, I will definitely answer all of them. And if during the talk there are any questions or clarifications that you feel is going to affect you following along, please feel free to interrupt. And if I miss it, Professor Naren, I request you to please kindly stop me so that I can address queries then and there. Like Professor Naren said, I have a background in electronics and communication engineering. I studied ECE way back in a different life. At College of Engineering, Gindi. And while after that, I was doing an MS in communications engineering. And while I was spending a lot of time researching efficient coding and decoding algorithms for communication systems, what I found, what I had to do actually was to be a teaching assistant and teach many undergraduate courses. So I taught everything from basic electrical circuits lab to digital signal processing to communication systems design projects. So during this time at Ohio State, I also took a course on teaching and learning in engineering. And this is what kind of kickstarted my interest in the process of human learning itself. So several years later, I was contemplating whether I wanted to get a career in teaching, teaching engineering. But then I came across this interdisciplinary program in educational technology at IIT Bombay, and they were doing a lot of work on incorporating technology into engineering teaching and learning. And so I thought that this is a field which gives me the opportunity to kind of study what are the learning processes of students as they are learning engineering. So this was why I did my PhD in engineering education. In fact, I studied how students solve very complex kind of engineering problems called engineering estimation problems, and how we can support them in this process. Now, what the reason that I'm sharing my background is that I want to kind of relate that my experiences are perhaps very similar to a lot of yours. I came at it as a student of engineering, and then as a teacher of engineering, and then I evolved to become a researcher of engineering. So I kind of have all of the perspectives on engineering and engineering education. And so from that perspective, I'll try to share with you some of the recent work that we are doing in trying to rethink the way that we approach engineering education itself. So that's the name of our project, a holistic reimagining of engineering education, where we are trying to rethink the way that we teach engineering at IIT Gandhinagar. So before we go any further, to make sure that all of us are active and engaged, you can scan this QR code, which will take you to a Google form. There are just 2 questions. I would request all of you to answer these questions. I'll give you 3 or 4 minutes, and then we will kickstart the rest of this talk on the basis of the responses that I get over there. So please, you can use your mobile devices. Just I request you to do it in landscape mode. Or if you want to do it on your laptop, that's fine too. But please go ahead and let me know if you can't access the form.
Yeah, can you just also put this link in the G chat?
I will do that. Yeah, I will do that.
So that people who are there in the system, they'll just click it and then they'll be able to see that.
Yeah, I will do that. So this is a habit from class, right? When I go to class, I do these activities, and kids are usually sitting there with their mobile phones. So you put a QR code and they'll immediately pull out their phones and start doing the activity. So I hope all of you can see it on the chat now.
It is there in the chat and it is opening also.
Okay, fantastic.
Oh, so that means it's very, for something we need to put it as 14th, and everything looks as though they are important.
It's a ranking.
No.
So yeah.
So
everything cannot be equally important. This is where
Yes.
I want to understand your perceptions.
Right.
So just to put some pressure on you, I know that you're all teachers and you're usually in the other role, but still, we are 3 minutes in. So I'll give you all another minute or so, and then we'll close the survey and we'll move on so that we can also discuss other topics.
Yeah, because I think because now we are like kind of confused which one to put it in 14th.
Exactly. So that is, but
Because
please don't. Please don't overthink it. Like, there is no right or wrong answer. I really want to try and understand what are your perceptions so that we can move on from there. So please go with your first instinct here. Okay. So I have got about 7 responses, but I'm going to move on now. And here is a okay. So here you can see a little bit of a word cloud of the responses that we got for this. And you can see that there is some emphasis on problems, on designing, and on people. So there is some sense that engineering is something about, coming up with solutions, about designing products, and about helping people. Right. In terms of response to question 2, in the interest of time, I'm not pasting it, but what I saw was that most of us felt that having the base of engineering knowledge and having the base of problem analysis skills were the top 2. And then the third one was usually designing and developing of solutions, right? And so there are no, like I said, there are no right or wrong answers, but most of us feel that having the engineering knowledge, being able to do problem analysis and design solutions are the top 3 attributes for our students. So what I'm going to show then is that at IIT Gandhinagar, we had a slightly different take on what it means to be an engineer and what kind of attributes are important for an engineer. And we accordingly redesigned our curriculum and our courses in that direction. So what we kind of recognized is that there are many problems facing the world. And one of them, for example, is growing responsibly. How do we grow in ways that are inclusive, that are sustainable, that are efficient, in terms of healthcare, in terms of education, in terms of energy, in terms of transportation, all kinds of things, right? So if you look at this scorecard that is there on the right, this is like the Sustainable Development Goals scorecard, right? And as you can see, as a humanity, we are falling short of these goals. Now, these goals are not something that a single person can address, not even a single community, a single company. But this requires cross-country collaboration and an expansive imagination. So what we are saying is that our engineers are the ones who are going to have to solve these problems, and therefore they have to be prepared to tackle these problems. And in order to tackle these problems, we need to reimagine engineering education to train our students to be innovators. So, like I already said, these are some of the goals of engineering education that have been brought in, by organizations like ABET, and within India, NBA. And so, keeping this problem solving and design mindset in the center, designing and developing solutions, conducting investigations, all of these have become very important nowadays. So in fact, in all our curriculum now, we have one course at least on engineering design. We've also started to recognize that environment, ethics, all of this is important. So we also have one course on all of this in our curriculum. That's how our curriculum was before, right? But then we started realizing that if we continue to prize abstract conceptual knowledge, and design projects kind of continue to come as an afterthought, then is this the kind of engineering training that we want to impart to our learners? Are these the kinds of engineers that we want to create? Are these the kinds, is the kind of world that these engineers will create, is that enough for us as humanity? So with this question in mind, our founding director sort of redefined what it really means to have a good engineering education. And so when the institute was started, the definition of goals for engineering education were written up as deep conceptual understanding and authentic participation in engineering practices, which means that when our students graduate, they should be able to do everything that engineers do. They should be able to solve problems, they should be able to design things, they should be able to debug, they should be able to understand society, they should be able to communicate, work in teams. All of those things should be ready off the bat. So it should not be that they need training after that. They should be ready for this when they graduate. And most importantly, we want them to feel like they are engineers, like they are innovators, right from the start. Yes, we want them to get jobs, but more than that, we want them to get to the top of their jobs. We want them to have the confidence to start up, to innovate, to think about innovation, and to do some complex work right out of their engineering education. But then what we realized is that this kind of goals, these are very lofty goals. These are not easy to achieve. And this requires actually a radical rethinking of the way that we do engineering education, the way that anybody was doing engineering education in India, at least, right? And the third thing we realized is that attaining this kind of learning is not simple. It's not only a matter of the brain. It's not only a matter of giving some knowledge to the students, right? It's not a matter only of changing their brains, but there's a lot of other things which are involved in this kind of holistic learning. So their cultural background, their economic background, the resources that they have access to, how often they participate in engineering activities, what they believe about engineering, what they believe about themselves, what they value in life, right? Who is around them? What are their teachers telling them? What are their peers telling them? All of this becomes important if we want to um, make the kind of engineers that we want. And someone had a question, someone had a great question, in fact, in the survey that Naren had sent out, that what do we do for this holistic development of our students? Exactly, that's the question. We want holistic development for our students. So what do we do? And so essentially what we had to do was rethink how we were going to do engineering education right from the beginning. And what we did over here is that we created our own engineering learning pathway, right? And where does this pathway begin? This pathway begins when the time that the students enter our institution, they face what is called as the foundation program. And in the foundation program, for 4 weeks, they have no technical activities, right? For the first 4 weeks, there is no courses. All they do are a lot of activities in creativity, in teamwork, in sports, in leadership, in social cultural awareness, values, ethics, all these kinds of things. In fact, they learn pottery, they learn how to dance, they go out and visit the army base, which is near our institution. They go into the villages and they kind of see how people live sustainably over there. So the first 4 weeks is about them just understanding that they are humans first, and what is their place in this world, and what is their place in the world as engineers, right? To understand what is this profession of engineering really about. Once they have had this really immersive experience, then we start their coursework. And their coursework actually comprises 2 years of a very broad-based curriculum, which means every student for 2 years is taking the same set of common courses. And these include everything from engineering graphics and coding to design thinking, prototyping, history, philosophy, biology, material science, electrical engineering. Everybody takes a broad-based curriculum. It's only after 2 years that they go into their respective department core courses or electives. And even there, they have the option to do minors and things like that. So the core idea of our curriculum is that we kind of realized that in order to make students holistic engineers, we need to give them holistic opportunities. We cannot be putting them into narrow silos and expecting them to be holistic engineers. So where did this actually come from, right? So there is a whole lot of educational theory. There are some references which I've cited over here, but there's a whole lot of educational theory which says that learning experiences should be personally meaningful and authentic to learners, right? Now, there was one question again from one of you who talked about, this is a problem in engineering education, and people come without any aptitude for engineering. Now, I would argue that it is not really an aptitude for engineering, and this has been shown in research as well, that we shouldn't really think of our learners as deficient or as weak or as lacking in something, but really all of them have some resources, right? It's just that their interests vary, their motivations vary. And when they're not interested or motivated, then all of these preliminary resources that they have with them in their minds will not be triggered, right? They will just be sitting in class, not interested, not relating to anything that we are doing. So we need to give them a learning experience which brings their interests to the center, right? We have to make them do activities which are meaningful to them, which center their interest, their culture, what they value in life. And then there is a lot of research which has shown that when people work with materials, right? So in engineering, we have a whole lot of that, right? Engineering is all about creating artifacts. So we can do a lot of that. Even if it's a code, they are making something. So when learners make something, when they are creating something, that is when they become interested. That is when they become committed to the process of their own learning, right? It also brings to the forefront their own intuition, which they have about certain things. And at the same time, it prepares them for future learning experiences and allows them to learn practices such as design, problem solving, and so on. So, what this was kind of our argument, that we want to tap into the interest of our learners so that they become committed to engineering, they become motivated, and so on, right? So how did we then start doing this? One of the things we started doing was that we started running a lot of courses in project-based mode. Okay, and to support, sometimes a course, there are entire courses which are only projects. Sometimes, for the most part, there is theory which is complemented with the large open-ended projects that students have to deliver at the end of the course. This has been supported by a growth of this makerspace culture at our institute. Now, a lot of you may be familiar, makerspaces are places which have, easily accessible prototyping tools like 3D printers, laser cutters, and so on, where people just naturally they come there and they start making things, and they do whatever they want. They start tinkering and things like that. And sometimes they are, like the one over here that we see, this is our institutional makerspace. The one on the right is our institutional tinkerers lab. These have, so-called the actual prototyping tools, but then also we have other places like the Center for Creative Learning, where we work with really simple tools so that learners can make something, just like paper and Lego and MDF and things like that as well. The key point is that it has to be a space where learners can realize whatever ideas they are having for their project. So we have been finding a lot of interesting things when students do these project-based learning courses. And I'll say a little bit more about the structure of the courses and so on and upcoming, but I just wanted to give you some examples of what are the kinds of things that our students are actually accomplishing. And these are first and second year students as well. So what you see over here is this was a first year design and prototyping course, and we gave them a very simple mandate. We said you take a household object and you make one value addition to it, right? But then this is a group of students who liked to play cricket, and for them the value addition was some kind of device which can throw the ball while the batsman is practicing at the nets, right? So without being asked, they learned the prototyping, they applied the right prototyping skills, and they have made this device which actually worked. It was able to throw the tennis ball when anybody is batting, right? So you can see that their own personal interest has come to the front when they have learned a lot of concepts. They have learned, of course, how to prototype. They have learned all your workshop skills. They have learned your metalwork skills. All of that is there, but they have also learned how to actually apply concepts of mechanics, and the dynamics in order to design this object, right? The second one over here, it's a very naive looking box, but essentially this is a box wherein there was a course where they were asked to make, again, solve some problem, right? Any problem which they see around them. And this was a group which said, phone addiction is a very important problem, and so they're going to make sort of this security box, and once you put your phone inside, it's locked and it cannot be opened for 2 hours. Now, there are many such objects in the market. That is not the point which is interesting here. The point which is interesting is that they were only asked to make mechanical things, right? But this group brought in electronics over here because they were correspondingly doing a basics of electrical engineering course, and they felt that they could apply it over here. So what we see here is a natural disciplinary integration happening. Someone had a question about interdisciplinarity. Of course, interdisciplinarity is important, and when we have students do projects, natural interdisciplinary things happen. And the final thing, which is sort of my favorite example, is this little mechanisms course, which this is a slightly advanced course. It's a third year mechanisms course where learners had to make a mechanism with a single point of freedom, right? And what they had to show was that with only moving one thing, they could make all the other parts move. So what they have done is, just by having that rotation, they are able to make 3 other parts move, and the 3 parts are the drums, this keyboard, and this little creature who is playing the guitar. So the entire, all 3 musical instruments are playing just by the rotation of a single handle. Now, here 2 interesting things have happened. At least 2 interesting things have happened. You could not hear what the student was saying, but she told me that it's only when they did this that they realized that music is actually periodic, because they are able to move a single thing and all 3 of the instruments are playing at the same time. They were able to recognize, understand truly deeply this notion of periodic motion or oscillation. And the second thing which happened is that at the end, this girl told me, now that I've made this, I feel like I can make anything. So this is an increase at the same time also in their confidence, in their ability to be able to innovate. So these are some of the nice things that we have been following along, that these kinds of learnings happen when we do these project-based learning courses. But the issue with these project-based learning courses is that while we do have some literature on how they should be conducted and how we should support learners during these courses, the literature is also a little open on this. So some of the work, specifically like how does learning happen and how can we design to make learning happen. So specifically, what should the structure of the course be? How should I support my learner? How many TAs will be needed? When should I provide support? When should I not provide support and let the student fail? So there are so many questions which come up. And these are the kinds of questions that we at the HRE project try to answer. Me and my team, we come in, we actually do the research in these courses. So we kind of study, what is happening when these students are making these projects, and then we give the feedback to the teachers that this is how you should potentially be redesigning the course or supporting the students and so on. So I'm going to go into detail into 2 shifts that we did to bring in project-based learning right from the first year for our students. So, of course, the first shift, like I said, was a shift to this culture of design and making. So once the makerspace came in, people could make whatever they want, but then we realized that the traditional engineering design process, the conceptual design process that we teach them, is not enough, because um, in order to make good designs that will be adopted, that will truly solve human problems, we need to first teach our students to understand what are human problems. So we incorporated this course called as design thinking, which essentially trains students to, in a very systematic way, to understand what is the problem really that is happening, what are the learners' needs, what do they actually need to solve the problem that they are having. So they really have to think very deeply about the problem, and not just say what is the nearest technology that can help to solve. But and design thinking kind of goes hand in hand with prototyping, right? So if you in fact, building the prototype is something which helps us understand the users better. And when we make the prototype, we can understand the user better, the problem better, we get new ideas and so on. And so what we did was, we said, okay, we'll have a course on design thinking and we'll have a course on uh, uh, prototyping. So that was this course structure that we had before, right? And in that, what would happen is that the design thinking part was happening in one semester, and then in 2 separate semesters they were learning how to prototype. Now, what we saw was happening over there is that then during the prototype stage, they are just prototyping. They are not really thinking about the problem at hand, because we want them to start thinking about the big problem that they are solving. We want them to innovate. So, if they are not, if they are, the 2 courses are separate like this over here, so one is going on in spring and one is going on in winter, so then they are not thinking about what is a particular problem at hand when they are building the prototype. On the other hand, then what happens when they are doing design thinking is that they don't have the right prototyping tools to make the prototype better. So then this led to a revision in the course in the following into a single course, and it's called Design, Innovation and Prototyping. All our first year students take it either in the first semester or in the second semester. It's a 5-credit course, it's a purely project based course, but that doesn't mean that they are only doing the project. From the beginning, they have very structured activities which train them in the design thinking process. It trains them, how do we think about users, how do we think about problems, how do we visualize the entire transition from an idea to a product. How do we think about mechanisms? How do we think about materials? How do we think about adding value through technology? Right? So now the entire focus is shifted to a user-centered design activity. So I'll give you some examples of this in this video. Again, it has no sound. So here you can see that they learn structured ideation techniques, they learn sketching, they learn different types of sketching, they learn design thinking, which means thinking of the problem from the user's perspective. How will the user experience the problem? How will the user interact with the system? what is the user's experience, what are their challenges, and then they go into prototyping. They make multiple types of prototypes. They may make a CAD prototype, they make a paper prototype, cardboard prototype, then they go into maybe a laser cut prototype or a 3D printed prototype or an electronic prototype, whatever it is, right? And through this entire process, there are a whole lot of TAs and the instructor who is constantly supporting them. And of course, we as researchers are there following a subset of the groups as they are going through and making the things. We are documenting what are the challenges that they are facing, what are the difficulties that they are having. This is an example of an office hour where our instructor is helping the learners with their queries and so on, right? So this is sort of the way that our course proceeds. I'm not going to go into detail, but since we are actually doing engineering education research, we also try to document and systematically research some of these things. In this study, where we went from 2 separate design and prototyping courses to an integrated course, our hypothesis was that this would impact our learners' self-efficacy, which means their own confidence to be able to do engineering design and so on. And so we measured this using certain instruments which have been created within the literature in order to measure what is called engineering design self-efficacy, their confidence, motivation, success expectancy, and so on, and then their confidence for innovation and interest. And what we found essentially was that, as you can see from the highlighted points, the the course which was integrated design and prototyping had a higher self-efficacy for the learners compared to the previous course. So this now gives us some confidence that yes, this integration between prototyping and design thinking is necessary. And so now we have stabilized this course structure so that everybody gets to experience this course. So I'm going to take a pause at this moment and see if there are any questions. Somebody wants to unmute and ask.
There are no questions in the chat. Maybe I'll ask my colleagues if they have any questions, they can put it in the chat, or maybe if they can unmute and also ask.
Yeah, you can unmute and ask. There's no formality here.
Yes. Right. So as I think, I just have the first question. What is the kind of student size population that you handle for this course?
Yeah. So our current student strength is 360. Every year, as you know, the IIT intake is growing, and this batch, we had 360 students. So that meant we had groups of about 40 or so groups of about 8 or 9 people each. That was how we were handling it.
Okay, so that means for every 40 students, there is one kind of a facilitator or a mentor or something like this for this course.
Kind of, no. So the lectures and so the design thinking lectures and all that are handled by our design thinking instructor in a huge auditorium. She also oversees the design thinking labs in the same auditorium, along with some maybe about 10 of no more than that. We have about 20 TAs. Right. And these TAs then will also hang out in our maker spaces. So in the maker space, tinkering lab, workshop, all of them. Yeah. Every time the students are supposed to go there, they will be there, and they will be providing something.
So that's nice, because just to give a parallel, we also have a similar, like your course structure one that you said here. That you said a little while before, that where you have your design thinking as a separate course, and then there is a follow-up prototyping course. Now, we don't have that follow-up prototyping course, but actually we have this design thinking course which tells on ideation, empathize, and just defining the problem and arriving at some conceptual solution. the context in which I was asking the question was like, because here we are about we handle about 20 sections. Each sections will have about 60 students, so about like 1,200 students, and it is taken by each section is independently handled by about like a faculty across different domains. Now, how we have here, like I go for one class, my other colleagues go for other sections, and we independently handle, though we have a common material. And the students are also from across different disciplines in that section.
Right.
Some
It's
of my
the same for us.
Yeah,
All
some of my
360
colleagues
are
are also
same.
here.
Yeah.
Yeah. But we don't do that kind of prototyping. We just stop there at the conceptual selection,
Right.
and then kind of thinking on what is the best solution or recommended solution, and we just stop there. So, but I think this is a good idea to have a kind of extended course on that. There's one question which somebody, you can just take it up.
Yeah. So in group projects, how are students evaluated individually? So there is a lot of that's a great question, because we always get this question about evaluation, and our instructors have given a lot of thought to this. So there is always an individual evaluation component as well. So it's not that the entire 50% of the evaluation will be on the project, and 50% of the evaluation is based on their individual work as well. So like I said, there are these design thinking activities, and then there are these prototyping trade trainings. So when they learn prototyping, right, over here they learn them as trade. So they will learn 3D printing trade, they will learn workshop practice as a trade. So they have individual grades for that. They have individual grades for all their design thinking labs. In the project, in the interest of fairness, we have a component of peer evaluation. So what happens is, learners cannot ideally, if there is somebody slacking off in a group, then it will come up, because you have to evaluate your peers, and there is only a particular amount of marks which can be given to the whole group. So there is a lot of negotiation among peers, and you do not want to be seen as the one who did not do any work. This is a very good way we have found, not only to make sure that teamwork happens, but also that teamwork evaluation is fair. So that is the way we evaluate it, by having components of individual and group work. How many learning hours per individual? So they do 3 hours of theory and 3 hours of practical. Their theory is, the lectures plus the labs and so on. And then they have 3 hours of training for the trade. But of course, closer to the end of the semester, which is the last 3 weeks, when they have to deliver on the project, then we stop counting hours, because then they are working 24/7 in the labs, in the makerspaces. It's up to them at that point, because they have to make a video, they have to make a presentation. We treat them very professionally. I guess that is one of the very important things. Like I said, we treat them as responsible adult engineers, right? They have to be able to describe their product to us. They have to be able to describe why it's a good product, why it works, why it solves the problem. So by giving them this sense of responsibility, I think we get the best effort out of them. So without, and also by coming back, Professor Naren, to your point about the prototyping, we really believe that the prototyping is very important to close the design thinking process, because it's only when people make, even if it's a very simple paper prototype, that they actually realize what are the challenges with their ideas, right? And this is true if you look across the engineering profession. This is true, right? So why should we not give our students the same opportunity, is the question that we are asking. There are a couple of more questions that I'm quickly going to. Where did it go?
You want me to read the question?
Yeah, that's okay. Does the specialization? No, specialization doesn't matter. Everybody is taking this course. Like I said, first 2 years, no specialization. Everybody is taking all courses. Design thinking should be taught to students of all domains. I completely agree with you. That's what we are doing. Everybody gets design thinking. In fact, some of our computer science students will come and complain to us that why are you teaching us design thinking? We are never going to make anything. And then we point out to them that even if you make an app, you need design thinking. So I think that works out quite well.
So, Aditi, this is Vignesh. I
Yeah.
have a couple of questions.
Yes,
One
please
is
go ahead.
the stage from empathize to define, right?
Right.
So I teach that engineering design course at SASTRA. So one of the difficulties that I have seen is moving from the empathize to defining. You know, how do you really know this is what you need to do?
Yes. Yes.
Right? That itself is a very big
Yes.
leap for the
Yes.
students in terms of their cognitive,
Yeah.
the shift in the mind that they need
Yeah.
to bring.
Yeah. Yeah. Yeah.
So you have put all these into a semester. So I'm just wondering if how do they manage in that short time they are able to do that change in the shift in the thinking
So,
process.
yeah, I will show you the next example. I'll show you exactly how this shift happens as well. You'll see a very nice, very clear example of a course where there was no design thinking and where there was design thinking. But I want to tell you, I want to hear talk about the person who does this. So our instructor who teaches it, she is a designer. She is a trained design person, right? She's not an engineer, she's a design person. So what she does is that she actually has these design thinking activities where they, after empathizing, they come up with a set of words that describe the problem, and then from the basis of that she scaffolds them to come up with a project brief. So coming up with this project brief is in fact one of their major milestones for which they are evaluated. So it's a very highly scaffolded process, and if you would like, we could be in touch later on, and I could also put you in touch with Mansi who teaches the course. But it's a highly scaffolded process where once they empathize, once they develop these user personas, once they identify what are the words associated with the problem, she then teaches them how to put these words together to come up with multiple briefs, and then choose one brief which best describes the problem. And they usually do this by 1/3 of the course in, they have come up with a project brief, and then 2/3 of the course in, they have their paper prototype, and then in the last 1/3 they make their final prototype. So this structuring is very important. Of course, what you're seeing here, the structure has evolved across 3 iterations, but now it is fairly stable.
So that comes to my another question. So here you're doing a sort of a scaffolding so that students can arrive at the project brief, right?
Yes.
In terms of the vocabulary that they need to do or how they need to phrase.
Correct.
So now, but when they go out, graduate, these scaffolding may or may not help. They may have to do it in a very different way when they graduate. So have you looked into, or I don't know, this 3 semesters, you have 3 years you have done, so maybe students are yet not graduated into workplace and not yet you have, or do you have a sense of if they are going to do well in their workplace? Is there some insight into that?
So, the whole point of the whole definition of scaffolding is that it should be done in a way that once the skill is acquired, it can be withdrawn and the learner will be able to do it by themselves. That is the whole notion of scaffolding. And so that's how it is designed. It's not just designed to do this task, but it is designed for them to learn to do similar tasks. That said, it's right that we have not yet evaluated how they have done in the workplace, but we do have evaluations of, let's say, the first year batch now being in 3rd and 4th year, and they are applying, they may be doing a separate, like they may be doing a project-based course in their 4th year, or they may be doing an entire project in their 4th year. And what we see is that they are applying this. This is, of course, anecdotal evidence at this point, because I work with these students continuously. I know that they are applying this in those courses at least. Without us asking them, they are translating it to a new situation.
Okay, that's
Yeah.
great. Yeah, thanks.
Yeah. Thanks. Professor Naren, I think there was one question in the chat that I missed. Could you please read it out?
Yeah, one was like you already answered the one from Dr. Kannan. The other one from Dr. Vidya is whether design thinking should be taught to all the domains.
Yeah, I did answer that as well.
Okay. Then the
I
next
think,
one
yes.
is I feel a syllabus to be framed for the tools of innovation design thinking that includes tools for visualization, journey mapping, value chain analysis, mind mapping, rapid concept development, assumption testing, everything.
Yeah.
Right, storytelling and everything. So I think this is a kind of a question which Dr. Prabhakar is asking, whether the course also teaches or exposes the students to these tools. Am I right,
Some of
Prabhakar?
these.
Yes, sir. Actually, there is a lot of tools are available to support all these things. Either it can be online or offline. To what extent the students will be learning about the sprint-based mural and what are the exact uses of co-working together. So whether all these things can be included in the syllabus so that the students will get accustomed with the different tools that will support in the design thinking process. That's what I wanted to say.
So of course, there are a lot of tools for design thinking available out there. You're absolutely right. So our instructors at our institute, we choose a set which is appropriate and doable within one semester. The point is we give them a basic introduction so that they are able to, start off with design thinking. And this is what we usually do. We make sure that their foundation is strong. After that, we just mention to them that these all tools and techniques are also available. These are called extension activities. And then the students can choose to take it and use it any way we want. So our emphasis is on a strong foundation. So we can never teach all the tools available, but what we are trying to do is make our students sort of self-directed learners. So the idea is during the course, we give them a basic and then they become self-directed learners. They go and choose the exact tool that for this thing, do they want to do mind mapping? Maybe they don't want to do mind mapping. Maybe they want to do other kind of visualization. So that's up to them. But the fact that they should have some kind of mind mapping, we tell them, then they can use whatever tool they want, right? So that's how we proceed. I hope that answers the question. Yeah.
Yeah, thank you. So I think maybe we can proceed.
Yeah. So, right. So, the other thing, like I said, that we started to do, I already said we were doing project-based learning. Now, project-based learning, I think a lot of you must have heard this. It's a pedagogical approach that has got a lot of traction within engineering education. The challenge, of course, is that a lot of the time we do project-based learning with older kids, third-year kids, fourth-year students, and sometimes even graduate students and so on. But for first-year students who have just come in, we always hesitate a lot. Like, will they have the basic knowledge necessary to even do a project? Or they are very immature, they have just come from 12th, they don't have anything. Yes, to all of them. But like I said, we have this philosophical approach where we don't treat our children as, deficient, our students. I'm saying children because that's how I see them. But we don't treat our students as deficient in any way. We say they have some skills. Let's work with them on that skills and scaffold them and make them feel empowered, right? So then what we did was we coupled this design, innovation and prototyping course with another course which is called the World of Engineering, which is also a project-based engineering course. But the major goal of this course, it also proceeds very similar to the design thinking course, but it's not a formal design thinking course, right? But this is the first thing that they experience, right? And what is interesting about this course is that we just want to get them excited about engineering, right? We just want them to feel that engineering is something where they're going to do something meaningful and not be writing math equations all the time, where they are going to make something where engineering has a chance to change the world, engineering has a chance to positively impact society, to intervene in the world and do something good, right? So that's why we introduced this new course called World of Engineering. And largely, it has a lot of case studies of engineering marvels. It has lectures related to how engineering, where engineering has done good. What is the difference between innovation and frugal innovation and jugaad and things like that. And again, it's completely project based learning. So here the teams are larger. They work like, it was the same batch size, 360, and they worked in teams of 30 to sort of ideate on a problem that they saw in the world around them, conceptualize, prototype, debug, and so on. So as you can see in this structure, the emphasis was there was this iteration between debugging and prototyping, right? But there was not enough emphasis given to the feedback between debugging and ideation and conceptualization. But what we did was, in this course, we spent a lot of time getting the students to try and understand what is a problem and what is a problem that is worth intervening in technology, right? Because there is a lot of and this happens a lot with students, where the minute they learn technology, they think that that technology can solve every problem. But there is the notion of appropriate technology and appropriate intervention and so on for the problem at hand. So in this course, literally half of the time was spent just in looking. Literally, the instructors ask them to walk around the campus, look around them, and see what are the kinds of problems that students are experiencing. And then in the second half, they again did some prototyping and debugging and so on, right? And then at the end of it, they had to do a lot of project management. It's a team of 30, so they had to divide the roles among themselves. Who's going to do documentation? Who's going to create a pitch for it? At the end of the semester, there was a pitch, and there was a judging, and people came and gave them feedback. People from the innovation cell came. So it was very serious for them. It was like, which of our great solutions to this great problem is going to be voted as important, and so on, right? And then this is now coupled with the design, innovation, and prototyping course, which I previously talked about. So what you see, the difference between the two courses is that the first course is more larger, just to get them excited about engineering and about doing something good. And then the second course actually gives them the tools to think more carefully about empathizing and defining and all that, right? And this was an experiment, right? Because we want to have these two courses. We know that these two courses are important, but we don't know how to situate them in what order and so on. So this is something where we are constantly innovating, we are experimenting, and we are listening to our learners on the ground, and we are trying to do it. So how do we do this? We started out in the World of Engineering course, meaning our team, and we keep following a team along as they are moving on their journey of building a solution to a problem, right? So in the first course, there was this learner, there was this group who wanted to design a solution to keep toddlers safe, right? So here you can see that we follow along as they do their ideation, they do their preliminary prototyping, they did some coding, and then on the right over here is their final product, right? So we watch as they are, what are they doing, and they have, this is for our research, but for their studies, they have like 30 TAs who are kind of helping them to think about the problem, and the instructor has office hours, and all of that support is given to them. But we are trying to observe and see what is still not working, right? Where are our students still lacking? And what we found was that this is sort of a clip, and what I want to direct your attention to is the conversation between one of our researchers and the participant. And what we find is that the students did not have the tools to understand the problem, right? So they prematurely constrained the problem. Like I'm sure all of you know, in design thinking, we first diversify and then we constrain. So the problem that happened here was that while getting them excited about engineering, they got very excited about engineering, but they didn't have the tools yet to think about the problem in a systematic way, to do this divergent and convergent thinking. And so they prematurely constrained the problem, and they could not understand what was the real problem of toddler safety, right? They just said, we will develop a solution there, we will have a some kind of sensor, and the minute the toddler passes the sensor, we will warn the parents, right? But if to keep toddlers safe, that is not the only problem. There are many other problems, as parents will tell you. So we found that they did not really understand the situation that they were designing for. And this kind of told us that they need a better understanding, you know, uh, and this is sort of a challenge of sciences and engineering thinking, where we like to compartmentalize very quickly, right? But the epistemology or the thinking of the humanities and the social sciences is expansive. It tries to problematize, it tries to understand what is the real issue at hand, it tries to think deeply about issues. What we found was that our students are not thinking deeply about the issues. So this tells us that there needs to be some more integration of the social sciences and the social sciences approach into this course before this course can truly be successful in terms of achieving its outcomes. So then what we did was, we coupled this course with the design, innovation, and prototyping course. And what I was just saying was, now they have acquired some of the tools of design thinking. And so now they are thinking in terms of, they are sketching what is the problem at hand. They are sketching the experiences, like you can see over here. They are sketching the experiences of the user. How will a user interact with it? How will these various prototypes look like? What will be the experience of the students with respect to various prototypes? Here you can see two, but they've also, they actually built 3 prototypes before they finalized on their final product, which was not even this. So what we see is that in the first course, while we were able to excite them for engineering and so on, not giving them this design thinking tool meant that they were not able to understand this, what is the actual problem in society, and so they were narrowing down their problem very soon. So this tells us that we need to rethink this integration even further, and we need to reevaluate this course structure, which is what we are doing across this break. We are trying to look at the data more carefully to see how we can structure these 2 courses, whether they should be in this sequence or whether they should be in another sequence, or whether we have to break these courses into a different way. So essentially what I'm trying to say over here is that when we need to rethink curriculum at such a drastic level, then we need to be very careful in terms of how we do it. So we need to, when we make changes, we also need to have people on the ground who are observing what happens when these changes are made, and how are our students responding to them then and there. Otherwise we lose them out, across one semester. That's like one batch of our students who are a bit lost. So what we are innovating on here is 2 things. We are innovating on the pedagogy, but also on the approach to the pedagogy, which is evidence based. So this is sort of the 2 shifts that I wanted to talk about. And then on the basis of these 2 shifts, I want to make some recommendations for how we think of project-based learning in our engineering curricula. And my argument is that when we are talking about making engineers who can design, who can solve problems, who can fit into society, who can be ethical, who can be environmentally aware, when we are talking about engineers who need to integrate across disciplines, then we cannot have a pedagogy that kind of teaches them things in silos, that makes them do well structured problems, that is sort of very narrow. We need a pedagogy that is also broad. Now, that does not mean that we are saying, do away with your theory courses and your labs, but we are saying we need to complement these theory courses with these project-based courses which support innovation, which support a sort of a deepening engagement with science and engineering, which support, especially which support certain attitudes like risk-taking, learning to fail, becoming confident, and most importantly, developing a positive identity related to engineering. So developing an identity as an engineer and not like an engineering student, but developing an identity that at the end of it, I am an engineer and I need to solve problems and I have the ability to solve problems. So some guidelines that I would say on the basis of this is that always our projects, whatever students are going to make, has to be grounded in personal interest. We have to design activities that will trigger interest. And what we find works most often is go outside, look outside the window, find something which interests you, right? That itself is a way to draw them in, right? No one is telling them to solve this, draw Carnot cycle or to, write a code to, classify books in the library, but someone is telling them to solve a problem that they like. That already engages them. In terms of resources, we don't always need full-fledged maker spaces. Low-tech, ed-tech, simple prototyping can be a great start, where we just use pieces of MDF, cardboard, paper, string. All of these can be great way to promote engagement in a practice of engineering. We have to focus on activities rather than technology. As far as possible, follow up your implementations with rich sort of qualitative studies where we try and follow our students and understand their learning process, right? It's not always the product. The first products that students make, I showed you some really nice products, but the first products that our students make will not always be great, right? But we want to see their process. We want to see that they are thinking deeply about a problem. We want to see that they are thinking of multiple options. We want to see that they are narrowing down. We want to see that they thought of 4 concepts before choosing one. We want to see that they thought of 4 materials and then decided on one. We want to see that they thought of 4 mechanisms and then thought of one, and why. So let's try and understand processes. In terms of research, yes, the methods that I talked about work. In terms of evaluation, our instructors have found reflection memos to be a great way, right, to get students to engage with this. So just once a week or twice, once in 2 weeks, getting them to write a few hundred words about what they did and why they did it. That works great. Allow sufficient time to iterate between, prototyping, testing, and so on. Because it's actually the reflection after making something and realizing that it doesn't work, right? Why doesn't it work? That is the point when the experience becomes meaningful. That is the moment when the learning truly happens. So we have to allow for those moments of failure. It's only in the moments of failure that the learning will really happen. And finally, facilitators need to be skilled. I know that this is a really difficult point for our institutions, but we need to try and make sure that our instructors are skilled. They need to be able to do everything that we want our students to do. The way that we find is it's not always the instructors who are doing this. We have fantastic lab assistants who are very dedicated. We have 2 people who are there in the tinkering lab, 2 people who are there in the maker spaces. They are fantastic resources to have. They have a lot of practical knowledge which they can share with our students. And so that's my points, and this wouldn't have been possible without our team at the HRE project. Specifically right now, Kamakshi and Samir, and also my former team members. So at this point, I'll take questions about this, and then I can also go back and answer some of the questions that were there in the form. So yeah, please go ahead.
So again, I think I would ask my colleagues, if they have questions, they can either put it in the chat or they can unmute and then ask.
If I may say at this point, please just unmute and ask.
Yes, so that's nice.
Because,
good.
Yeah.
So it's yes.
So I have one question.
Yes.
So you see the design thinking has a lot of other thinking also going on simultaneously. For instance, the reasoning abilities, the different kinds of reasoning that they do. We may not be sensitizing them to those things, but have you looked into those aspects? And it is not just the reasoning; it is also the abstractions that they do. They don't do it explicitly understanding that they are abstracting from a specific problem to a generalized problem. See, those abilities, does it get transferred in their other courses? Have you looked into those?
What do you mean by reasoning? Can you elaborate a little bit
reasoning
more?
As in when you define a problem, you'll have to I can't think of an immediate problem, but you will have to reason out and say that, okay, this is the problem that needs to be solved, or this is the solution that needs to be provided, and why the solution is a good solution for the problem that is stated.
Yes.
Right? That is a reasoning component there.
Yeah, so this is sort of the so this is the problematizing aspect, right? So really understanding what is the problem. So I mean, understanding what is the problem from a societal perspective, and then understanding what is the problem from the technological perspective, right? Now, from a societal, let me give you an example of the toddler safety problem. Now, from a societal perspective, the problem is to keep toddlers safe. Now, keeping toddlers safe, safety is a very complex definition. Safety can be, that they should not be kidnapped, they should not fall down, something like that, right? And now, the students have to understand this in all its richness. The second part is, then they have to focus, which of the one things that they are going to, which particular aspect of safety they are going to try and address. That is the first reasoning. Now, what we found, for example, was that if you want to keep toddlers safe, their definition of safety was that if the kids are playing in some play area, you don't want them to go out. So you keep we'll have a sensor. Their technological translation was, we would keep an IR sensor. The minute the kid crosses it, the message will go out, blah, blah, blah. But there are other aspects to this safety, right? The other aspect would be that the child could fall down. So what does that require? That requires some child proofing of the entire environment, and it requires maybe some protection on the child itself. The other thing, even if they want to prevent the child from going out, a very simple solution could be just to have a gate, which is the common solution all of us have right now. So there is this reasoning, and this is the reasoning which we find that students are having a challenge with. The other reasoning, coming up with the technology, surprisingly, our students don't have a problem with that. They are so in love with technology. They will find the right mechanism. They will find, I have to do IR sensing, and it has to go there. It has to be located at this location so that it doesn't block the IR. All of that they will do. But it is this reasoning process of truly getting to what is the problem, which is a challenge. And you're right, this is what we are currently working on. This is what we have narrowed into. And we feel that this kind of a thinking only comes when you start developing a social sciences way of thinking. When you move away from an engineering thinking and you come closer to a social sciences way of thinking, which is why we have more social sciences courses also in our curriculum right now.
Okay, okay, thank you. So, yeah, thank you for that.
Yeah.
So there's one question in the chat. I would read it for you. Product-based design thinking solutions are fine, but a service-based design thinking, how to go about that and like use that? Like if it is a service-oriented problem.
It can be anything. Actually, we never put a restriction on our students that it only has to be a product. It can also be a service. They can come up with a service-based solution as well. It has just happened that no one has chosen a service-based solution until now, a service-based problem until now. But in principle, the same rules apply, because even in a service, you have to think about how is the human beings interacting with the service, and in that interaction, what are the challenges that they are facing, and so on. So I think that component of design thinking applies in the same way. We don't restrict it actually, that they have to only do product-based solutions, but students like to do product. I think first year students really want to make something and hold something and show that they made something. They feel very proud of the work that they do at the end of it. So I think that's the reason. Yeah. Yes. Dr. Ramya.
Yeah, I have one question, and I too strongly agree that skills for the instructors are to be considered. And what kind of a strategy or any metrics are you practicing for upskilling means the mentors or instructors who is actually handling these kind of courses? What kind of measures you are taking?
Yeah. So so far, it is. So far, what has happened is that in this evolution stage, it is sort of self-selective, in the sense that instructors who are truly passionate about teaching design thinking, prototyping, making exciting students about engineering and so on, are coming forward, and they acquire the skills and the knowledge necessary in order to do implement the course, right? They are the ones who then have these training sessions with the TAs and the lab assistants and all that, and they tell them what kind of support to provide. So and these are sort of sometimes it's there's one session at the start of the semester, and then there are catch-up sessions every week where they have to tell what was the problem that they faced and so on. In certain cases, if the TAs themselves, sometimes we have MTech TAs who themselves don't know how to prototype and such, then we make them before the start of the semester to do some of the activities themselves, right? That is how it is done. That said, we have not yet had to do this large scale sort of training for our faculty at large if they want to teach this course, and that is something that we are working on now that this course structure is sort of stabilized. We would want that all the faculty be proficient in teaching it at some point or another. So we are now going to develop a training program, and it will involve this only. Like I said, the main features will be that they have to experience the course once, in parts as a learner, and then be able to do everything as a learner, and then teach the course. That is our main philosophy for teacher training or professional development. I hope that answers your question.
Yeah, of course, a bit. But still, the thing is, means interest and passionate towards this mentoring of this course, and that kind of a practice only here also we are following. And fortunately, I am also one of the instructor of this engineering design course in our university, and actually I joined in this team with an interest. The interest and passion actually makes the faculty or the mentor to learn, but still there should be a guideline or the platform if it is being practiced or anything, right? That makes the people to come forward and to give their contribution in a better way.
I
So
agree.
that's the reason actually I asked you that any practice you have it,
Yeah,
or
yeah.
that can be actually followed.
I agree. I agree. So this is new. I agree completely. But like I said, this is sort of new work. So far we have been working with instructors directly. So what happens is we are actually learning on the go what is working or not through our research. And so we are coming up with guidelines, what should be done and what should not be done. And as of now, we are working one-on-one with instructors, right? So we go and meet an instructor and say, this is working, this is not working, maybe you should do this. But then, like you said, I completely agree that we do need to come up with a training program properly. Otherwise, what will happen is that when the program becomes large, the quality will fall. All of that is very point well taken. So there needs to be a program, and I would highly recommend that such a program be there when you're starting off with, especially when you're incorporating prototyping and making and so on. It's very important. How will you? Yeah.
Okay, so any other questions from anybody? We'll just wait for. I am just curious, like I'm kind of self-inviting me and my colleagues to at least once visit IIT Gandhinagar to this creative space lab and then observe what we are actually doing. Because as I said here, the training the instructors to actually in this kind of course is really very intensive.
Yeah.
It's not only
Yeah.
time intensive, it is about their thought process, that streamlining.
Yes. So you're absolutely right, and I think that this sort of, it worked a lot in our case because it was a directive which came from the top, and our founding director laid down the importance of all of these things, and he gave the faculty the freedom to implement it the way they wanted. And then now we have a group of 6 or 7 really passionate faculty who have designed and redesigned this course to come up with that. But that said, you are always welcome to come and visit our courses when they are in session. Observe the theory classes, observe how our kids do the making and all of that. Yeah, definitely. I think it would help to have an immersion of that kind.
It would be glad, because most of the design teachers or the instructors who take this design course at Shastra are also in the same Google
Right.
Meet.
Yeah.
Right?
Yeah.
So that's nice.
So
you can go with the questions that you are. I mean, you can pick not all the questions. You can just pick whatever you think like you are interested to respond.
I had thought of answers for everything, but
Fine.
let me. I think how to address unmotivated learners and how to manage a heterogeneous class. I think this is, to some extent, I answered through my talk. This is a great point which somebody just made, that faculty with industry experience should be taken for these courses. That's a very good point. And very often we do have that. We have what are called professors of practice who come and participate with us, and they largely have industry experience. And so they lead the design courses as well. So how to address unmotivated learners and managing a heterogeneous class. I think to a large extent, this kind of a project-based pedagogy, I know we can't do this in every course, right? But if we motivate them from the start that what they are doing is something meaningful, then hopefully when they come to our theory courses in the second year, they are still a little bit more motivated, and they are they are willing to participate, willing to engage with the theory content, because they believe it will help to solve a problem later on. So I think giving them some task, and this is one thing that we have found, students just love to be challenged. They want to take on a task which is challenging to them. So if we give them a challenge, I think they will be motivated to engage. Now, this was a very involved question, but it was also a very interesting question, which is that what is the problem of teaching and learning in our country? Is it the volume of students? Is it the lack of faculty, the lack of infrastructure? And I'm going to, and are we just, using pedagogy as a way to shield all of this, right? So I'm going to say, I'm going to do a cop out that PhD people do a lot of the time, which is that yes, to some extent, everything, and it depends, right? Let me clarify that. Of course, the fact that we have students who are unmotivated is a problem, which is why we say let's try to motivate them. Of course, we have a fact that, of course, if we have faculty who are not knowledgeable, that's a big problem, right? We do need to have faculty who are willing to engage with our participants, with our students, who are willing to engage in the tough processes that we want our students to engage. So not just knowledgeable, but motivated, who believe in the process of teaching and learning, who believe that there is some value that they are adding to this process, to the students' learning. And of course, infrastructure. So it's a combination of everything. We do need infrastructure. We do need faculty who are knowledgeable, but we can overcome the student problem by applying the right pedagogy. That is my humble submission to you, that by reaching students at the point which interests and motivate them, by giving them a challenge, we can reach them at a moment so that they are engaged. What are our initiatives regarding personality development? I think these holistic courses, I talked about it, foundation program, project-based learning, all of these kind of target the holistic development of our students. This is a very interesting question. It's perhaps a bulk of what I teach in my course. How do people learn? Um, yes, people do not learn. Learning is not linear. We may have very structured courses that first you'll do mechanics 1, then you'll do mechanics 2, and so on. But it may happen that the student learned nothing in mechanics 1 and mechanics 2, but when they made a car in the project course, they learned everything from mechanics 1 and from mechanics 2. So yes, knowledge building, knowledge construction is an involved process. It is not a linear process, which is why it's a process where connections are made in our brains between concepts the more we have experiences. So that is why our goal should always be to give our learners as many experiences with a particular concept as possible. So either it is through, by making them to listen to our lectures, by making them do problems, by making them do some projects, or by making them, make a presentation about it, whatever. But the more number of ways we make them engage with the concept, with the skill, the more richer their knowledge of that will be later on. I think I'm going to skip this one. AI in engineering education. I think I'm going to comment on AI in education broadly, which is something that we have been hearing about a lot. Just like any technology, my point is very simple. Just like any technology, AI will work in education as long as we use AI to make students do the work, to think, and to create some supports in the process. In my mind, technology has these 3 roles, right? It is to make the learners do things, to make the learners use their brains, to make the learners use their hands, and to support them in the process. As long as we use AI for this and not to create summaries, not to copy code, we are good. Okay. So if we can think of creative ways to use AI to do these things, then yes, as a let's say as a Socratic partner who asks us questions, as a co-learner, right, who gives their ideas during a design session, as a teaching assistant. All of these roles, AI is perfect. Oh, this is sort of where I started out. What is the role of our engineering institutes? I agree, I'm going to talk with respect to engineering institutes because that is my space which I'm familiar with. But yes, we largely speak about jobs. We largely speak about making you people employable. But I think this is where we are philosophically becoming a little bit different now, and we are saying, no, we want you to be thinkers, we want you to be creators, we want you to be innovators. Um, so then we assume that once a person gets a PhD degree, they are equipped to take class. I agree, people are not equipped to take class just because they get PhDs. Myself included, I learned how to teach because my course was about educational technology. But I think I also learned how to teach because, you are a teaching assistant, you do take teacher training workshops. I think all of these are important and they are necessary. And I think we should not assume that just because you have a PhD, you can teach. And I think that people start thinking that they can teach, how hard can it be? But that's not necessarily true. There is a science to it, and a teacher training can help a lot. This is the final question. I know there are some more questions. I'm not going to talk about Bloom's taxonomy. Okay. How the last one I think I've answered, how to orient and engage just out of school students. That's the whole talk was about, largely about that. I want to say about engineering education research. It is not very vibrant in India, but thankfully as a community we are growing. I did have a few links for you. Let me just paste them in the chat. There was, in fact, a engineering education conference as well recently. So I would encourage those of you who are sort of interested in engineering education research to look at this. There is Research in Engineering Education Network. That is the first one which I just posted. The second one is Indo-Universal Collaborative for Engineering Education, and they recently had a conference, and they also conduct these workshops regularly that talk about engineering education. So I think as a community we are sort of slowly getting there, and it would be great if some of you can also start participating in this community. IUC especially, I think, would be very useful. They conduct workshops. Perhaps you can have people come conduct workshops for you as well. So I think it is a field which should grow, and I hope that now with our work and with other work it will grow as well. There are a lot of informal networks, by the way, but formally these are the two things which I found. So I think that's it. Those were the set of questions, and so I just wanted to say thank you for asking all these questions and for engaging in this talk. I'm sorry it took very long, but thank you all for being here right until the end.
Right. Thank you, Dr. Aditi. It is indeed very informative, and I think you keep us grossed that we could not see that there was so much time itself. So it is really nice. It brought about a different perspective of visualizing the engineering education. And most important thing is implementing it, learning from it. It's not like everything goes right at the first implementation, but keep iterating it, reflect on how we implemented the course, and then kind of strengthening this. That's key message. Yes. So I'm sure all my colleagues who shared, who joined online and who will also see this probably when I host this on YouTube, they would also like this kind of talk. I thank you very much for sharing a very good time long time rather with us, and this is just the beginning of our kind of collaboration, I should say, right?
Wow.
And I am sure that we will have many more such instances where we can meet. Probably I can invite you, and we will have such kind of exchanges and then work.
Yeah, thanks again for having me, and you are all welcome to write to me at any time. Aditi.Kothiyal@IITGN. You can find me. Professor Naren can give you my email address, no problem. And you are welcome to visit, as a team to see how we do things. We'll be happy to share our experiences with you.
Thank you. Thanks you.
Thank you.
I thank all my colleagues for joining and making it a very interaction sessions, and thanks to all.
Okay. Thank you. Thank you.
I'll just stop the recording.